who, after having a break in career, decide to return to mainstream science and work as bench level scientist. So, what is the eligibility? The woman scientist holding postgraduate degree in basic science, graduate or postgraduate degree in professional courses or PhD, have a break in career. And what is the age group? 27 to 57 years. So this is also very important for women scientist scheme. And the graduate aptitude test in engineering, that is for GATE. So GATE is conducted jointly by Indian Institute of Science and the Indian Institute of Technology on behalf of National Coordination Board, GATE, Department of Higher Education, and the Ministry of Human Resource Development, MSRD, Government of India. The following students are eligible to take GATES: the bachelor degree holders in engineering, technology, and architecture, 3 years after 10 plus 2 or 10 plus 2 3 ongoing or 10 plus 2 plus 4 ongoing or post BSc or post diploma, and those who are in the final year of such programs. Master degree holders in any branch of science, mathematics, and statistics and computer applications are equivalent, and those who are in the final year of such programs. List of companies. Many companies have signed the memorandums of understanding with the GATE organizing committee for using GATE score as a screening tool for recruiting engineers at the entry level positions. Bharat Petroleum Corporation Limited, Hindustan Petroleum, and Indian Oil Corporations, and Power Grid Corporation of India. So many companies is available for those who are eligible for GATE score. This company is asking for GATE students. National Thermal Power and the Punjab State Power Corporation Limiteds and Airport Authority of India. They also need for GATE course students. And the Tata Institute of Fundamental Research, TIFR, as yes, application forms will be released by Tata
चलना ना,
Institute of
वो बस कुछ
Fundamental
करना
Research
था उसमें से।
in the month of November. Candidates can fill TIFRGS application form on the official website of the Nationwide Science Entrance Exam. And the Baba Atomic Research. So the Baba Park also giving for JRF. They are conducting for entrance exams yearly 1 years. Those who are eligible doing for PhD in Baba Atomic Research Institutes, they are giving for stipend yearly for 31,000 per month. So next, now we will discuss about for our analytical chemistry. So that is also very important. Different method of separations. So that is very important. So method of separation, evaporations. So evaporation. So that's solution, that chemical solution. What kind of physical properties we can do for evaporation? Because all the solutions we cannot do for evaporations. Only particle physical properties there. That chemical, that solution only we can do for evaporations. Dear faculty members, any idea? Please giving any idea for what kind of properties need for evaporations? Any faculty members give the answers? Any faculty members? Divya, Tomar. Any faculty?
Yes, sir.
Yes, ma'am. What? So yeah, all the solutions we cannot do for evaporations. So what kind of physical properties there we can do for evaporation? Madam, any idea? Others or any idea, please?
सर
Students, sorry, faculty, any ideas?
सर प्लीज repeat your question.
Yeah. All the solutions we cannot do for evaporations.
Yeah.
So, what kind of physical properties there in solution?
I think low boiling point.
low boiling.
That is the main physical property which is responsible for the evaporation.
Okay, madam. We will. So no problem. So somebody giving for message. Okay, I will explain, ma'am. No problem, madam. And next distillations. So distillations, all the solution we cannot do for distillations. So what kind of physical properties need for distillation process? Distillation process. Okay, and fractional distillations. So, what kind of physical properties need for the in the solutions? Fractional distillations and the sublimations. So now I explain, no problems. So for evaporations, so evaporation, what is the physical property in the solution? Big difference in the boiling points. So that is very important for big difference in boiling points. So water and the salt. So that is water boiling point for 100 degrees Celsius and salt for nearly for melting point 1413 degrees Celsius. So this type of solution only need for evaporations. So big difference in boiling points. So that is very important for the physical property. So next for distillations, this is also need for big difference in boiling points. So water and salt, example of distillations, and the fractional distillations. So this is very important. Small difference in the boiling points. For example, ethanol and the water. So we cannot do for evaporation methods because small difference the boiling point ethanol and the waters. So this kind of solution we can do for the fractional distillations. So fractional distillations, what is the physical properties in solution? Small difference in the boiling points. And sublimations, the sublimation point of solids. Iodine, low sublimation point, 187 degrees Celsius, and sand for high sublimation points, 2230 degrees Celsius. So then for crystallizations, so what is the important solubility? Crystallization is what is the important physical property in the solution for solubility. Solubility is very, very important. So what is the example? Sugar, high solubility when hot and the low solubility when cold. So the crystallization is very important. What kind of the physical properties? Solubilities, the crystallization methods we can do for separations. And using for separating funnel, density of immiscible liquids. So we can do for the separating funnels. And solvent extractions. Solvent extraction for solubility in two immiscible solvents. Solubility in two immiscible solvents. We can do for solvent extractions. This method we can do separation because of salt and iodine in water and tetrachlorides. So two immiscible solvents, water and tetrachloromethanes. So these kind of solution we can do for separation, solvent extractions, solvent extraction methods. So, so okay. Once again, so next, uh, we can do a design. We can design any instrument. We should know about for what is the precision and accuracy. That is also very important. So nowadays, our gas chromatography instrument nearly for 13 lakhs. Our GC instrument nearly for 13 lakhs. Nothing is there, only for 4 or 5 parts. So what is the 4 or 5 parts? Carrier gas cylinder, and the injection part is there, and the next column, and injection part on the column, and the detector parts, and the data analysis. So totally 5 parts is there. But what is the price? Nearly for 13 lakhs. Our instrument, GC instruments. So we should know the how design the instruments. It's we can get so much money. So what need analytical chemistry is very important. So precision and accuracy, that is also very important. How we design the what is the precision? The precision refers to how close together a series of measurement or a series of measurements are to each other. How close together a series of measurements are to each others. That is for the precision. And what is the accuracy? How close a measured value is to an accepted value. Measured value is to an accepted value. So measured value, accepted value, that is for the accuracy. So please, dear faculty members, please consider this dartboard. Consider this dartboard here. Precision is possible or not, and accuracy is possible or not. Dear faculty members, any idea? Faculty members, any idea? No idea? Precision is possible or not? And accuracy is possible or not? Yes, Darsana, yes. Accuracy is not possible. Yes, very good. Precision is possible or precision is possible? No, no, not possible. What precision is possible? Because all the value close together, all the measurement value close together. So that is considered for precision. So here, when I throw the arrow is stick at the different positions, not very close. See, the 4 arrow is there in the on the dartboard. So different, so much distance, not very close. All the arrow is not very much close, very long distance. So one here, another one here, here. So very long distance, not close. All the arrows very not very close together. So here precision is not possible, and accurate also not possible. So here consider this dartboard and the following results, not precise and not accurate, because very large difference. This arrow and this arrow, see, very large difference, not very close to others. So very large difference. So that's why not precise. And then where is the accurate point? This red color is the accurate point. So not precise and not accurate. Please, dear faculty members, consider this dartboard. Precision is possible or not, and accuracy is possible or not.
Yes, sir. It is precise but not accurate.
Yeah, very good, ma'am. Very correct. Yeah, because of the all the arrow is very close together. All the arrow points very close together on the dartboards. So here precise is possible but not accurate. So first we should try to precision, then for accurate. So the precision is very important. So here this dartboard precision is possible but not accurate. This dartboard, please, dear faculty members.
Accurate
Sir,
and
both are
precise
possible.
both.
Yes,
Yes,
very
it
good.
is
Yes, both are possible. Very good. Yeah, because this is accurate points, and all the arrows very close to others. So here precision is possible. Sorry, here. This is for not precise, not accurate. Here precision is possible but not accurate. Here you see precise and accurate also both are possible. So this is for precision and the accurate. So guess my age, not by 30. So guess my age 30. So the value 29, 31, 30, 30. So here you both are possibles because of all the age value very close together. 29, 30, 31, very close. So here the precision is possible and accurate. What is the age of 30? So that accurate also possible. How close you are to the actual value? So that is for accuracy. Precise a series of value or each other or with each other. That is for the precise. Here, please, dear faculty members, here precision or and accuracy is possible or not? Precise and accurate possible or not?
Yes, both are possible.
Both are possible. My age 30, ma'am. That's my
Oh,
age.
in that case, not possible. Both are not
Accuracy not
possible.
possible.
So,
Precision is, yes, precision is there, sir.
yeah, precise is possible. Accurate also not possible because all the value close together 54, 55, very close. So that's why the precise is possible and not accurate. So precise is yes and accurate also no. So please this just my age 30. So here please consider this slide.
Both are not possible.
Yes, both are not possible because 25, 45 very long distance, not close together. Very long distance, 60 also, 90. So here both are not possible. Yes, correct. So here both are not possible. Yes, and accuracy and the precision. The ground for 500 feet. So the total 4 group is there. Each group each group 3 students. Among the three, the group one, among the 3 students, the first students running on the ground, 472.4 feet. The first student, and the second student running for 476.0 feet, and third students 475.3 feet. So total value for average value for 474.6 feet. So what is the ground accurate value for 500 feet? So here 474. So 474.6 the average value. So accurate definitely not possible because 500 feet. So accurate is not possible, but precise is possible because 474 very close for 475, 476. So accurate, so precise is possible, but not accurate. So this is the correct answers. And group two among the 3 students, the first student is 503.5 feet running, and the second student is 502.8, and the third student is 497.4 feet. So total for nearly for 501 average 501.2 feet. So here accurate and precise also for +1 or -1, that is no problem. So accurate or precise also possible because the value all the feet value very close to others. And group three, please you tell them, please all the faculty, please faculty members, the group 3 accurate precise is possible or not?
Both are not.
Yeah, both are not possible because 430, 480, very large difference. 430 and 880 large difference. So both are not possible. So this is also okay. And here, the among the 3 students, group 4, this is for group 4. Among the 3 students, the first students running on the ground for 64.8 feet. The second students 223.4 feet. And the third students running very fast, so much fast, 1211.8 feet. So what is the average value? 500 feet. Here both are possible or not? Here faculty members, here both are possible or not?
Both are not possible, sir.
No.
Accurate. Accurate is possible. Precision is possible or not?
For average, it is possible, but if we consider each and every student, then it is not possible.
Or accurate also not possible.
No.
Yes.
If we consider average, then it is possible, but if we consider individual, then it is not possible.
No, we consider for average. What is the average value? 500. So here both are not possibles because of precision is possible. Precision is not possible. 100% accurate also not possible. So when precision is possible, then accurate also possible. So without precision, accuracy is not possible. So precision is possible, then for accurate is possible. Precision is not possible, accurate also definitely not possible. So here you see precision is possible, here not possible. Very large difference, 64 to 23. So precision is not possible, 100% accuracy also not possible. So first we consider for precision, then for accuracy. So precision is very important. First we consider precision. Precision is possible, then accurate also may be possible. Precision is not possible, 100% accurate also not possible. So this is very important points. So consider this beaker and burettes measuring zone or burette, okay, which is more precise. Please consider this dot sorry, beaker and burettes, which is more precise.
Burette.
Any others? How, madam? How you are telling the answer for burettes? Darshana, ma'am. 6.2, 6.3, 6.4, 6.5. But in beaker you can see for 25, 50, 75, 100. So very long, the difference is very long, very large difference in the beaker, the value 25, 50, 75, 100. So here for 6.1, 6.2, 6.3, so the value very close to others. So that's why the burette is more precise. So the value is very close together is more precise. Here value is very large difference, that is for less precise. Okay. So next, this is for the cricket stadium. The bowler, here the batsman is standing here. So the bowler threw the ball, all the ball coming towards this side. The 6 ball is here. So here, precise, both are possible or not?
Precise, yes. Accurate, no.
Yes, precise is possible, but not accurate. Accurate is this part. So all the ball very close together. So all the balls very close here. So precise is possible, but not accurate. So this is the correct answer. No? Okay. So next, so how to measure for precision? Very in case lower value, you can see we can see for our eyes, but very large value nearly for 100 or 200 values there. That time how to consider, how to find out which is more precision, which is less precision. So that time so we can do for standard deviations. That is the main mathematical tool for used for test for the precisions. So what is the formula is, this is the formula for the standard deviations. SD equal to root sum of x minus m square. So the x is the measurement value 2, 4, 6, 8, 10, that is the measurement value. So 2 minus 6 whole square equal to 16. So this is the value. So this is for the average value, sum of equal to 40. 20, total value is the 40. So we can apply for this. So standard deviation equal to root 40 by 5, root 8, the 2.8. So this is the formula of 2.8. So now we can see the data 1 and the data 2. So here data 1, what is the mean value 100, and the data 2 also what is the mean value 100. So which is the more, which is the standard deviation, which is the more precision? Data 1 and data 2.
Data 2 is more precise.
Data 2 is more precise. Okay. Data 1 is okay. Now we can see. So what this is for data 2. What is the standard deviation is 1.5. Here what is the standard deviation is 6.4. Standard point is very important. So now we can calculate. Here the standard deviation is 1.5. Then here what is the standard deviation is 6.4. So lower the standard deviation is better for the, you should know about for error. So what is the error? Measured value minus actual value, that is for the error. Percent error, what is the percent error equal to absolute error? So absolute error divided by actual value into 100%. So that is for percent error. So percent error equal to, what is the error? Already we know, measured value minus actual value. So this is for absolute error. So absolute error, measured value minus actual value divided by actual value into 100%. So this is for the percent error. So what is the percent errors? So what is the actual value? 500 feet. It trials and the error. So what is the 503.5? So what is the error? Plus 3.5. This is the error. Here 502.8 feet. What is the error value? Plus 2.8 feet. And here 497.4 feet. So what is the error? Minus 2.6 feet. So this minus 2.6 feet is correct or not? Dear faculty members, plus 3.5, that is okay, and the plus 2.8 feet, that is also okay, but minus 2.6 feet error, this is correct or not?
This is correct.
Minus 2.6 feet is correct.
Yes, error may be positive or negative.
So keep in our mind, absolute error can never come for negative value. So absolute value, only positive error will come. So in case a negative value is there, we can do for this concept for positive. So absolute error only for positive value, the negative value is not possible. So this is also very important. The absolute error very important, only for positive value. So here 2.6, that is not correct. 2.6 feet negative error is impossible. Only positive error is the possible in the absolute errors. So okay, so this is, so what is the importance of significant figures? Significant figures are an important part of scientific and mathematical calculations and deals with the accuracy and the precision of numbers. It is important to estimate uncertainty in the final results, and this is where significant figure become very important. So rules of the determining the number of significant figures in a measurements. So total 5 rules is there. So what is the 5 rules? First rule, what is the rule 1? Non-zero numbers or significance. So this is very important. Non-zero numbers, non-zero numbers or significance. 72.3. Here 0 is present? No. Here 0 is not present. So 72.3. So what is the significant figures? 3 is the significant figures. Because of the rule 1, non-zero numbers or significance. Non-zero numbers or significance. 72.0. So this, the middle 0 is, the middle 2 0 is, this is called for captive zeros. So the captive zeros are significance. Captive zero means the middle positions. The 0 is present at middle positions. That 0 we are called for captive zeros. So this measurement has 4 significant figures. So this is for the rule 2. So non-zero and rule 2 for the active zeros. That is for the rule 2. And rule 3, what is the rule 3? If a number has decimal points, if a number has a decimal points, the trailing zeros are significance. If a number has a decimal points, that is called for the trailing zeros or significance. So what is the trailing zeros? See here 1.00. If a number has a decimal points, so here decimal point is presence, then the trailing zeros are significance. The trailing zeros are significance. So the measurement has three significant figures. The measurement has three significant figures. So what is the 100 faculty members? What is the 100 significant figures? 100.
One.
Yeah, yes. Because there is no decimal points. So only one significant figures. In case the decimal point is there, we can consider for all digital numbers. So here the decimal point is presence. That's why this measurement has three significant figures. So this is for trailing zeros. So, if a number has no decimal point, the trailing zeros are not significant. If a number has no decimal points, the trailing zeros are not significant. So, here 1500. So, here no decimal points. The trailing zeros is present, but no decimal points. Okay, has no decimal points. The trailing zero are not significant. So this measurement has two significant figures. So this is for the rule 4. And what is the rule 5? Leading zeros in a number are not significant. Leading zeros in a number are not significant. So what is the leading zeros? So this is for the leading zeros. 0.00. This is for the leading zero. These leading zeros in a number are not significant. This zero we are called for total rule 5 rules. So please now if we explain what is the 200. What is the 200 significant figure? What is the 200?
One.
Yes. Yeah.
One.
So next 3500.
Two.
2. Okay. Next.
One.
Next.
5.
So this is the answers. So consider this is for the answers. This is significant figure 1. This is 2. Here also 1. Because of no decimal points. In case decimal point is there, we can consider. But here no decimal points. And this is for the happy zeros. So we can consider middle zero called for happy zeros. So 5. Here also no decimal points. So 2. Here also this 0 is what we will call for the leading zeros. So sorry, leading zero, not leading zeros. This is for the no decimal points for trailing zeros. So this is for the trailing zeros. So this is for the answers. So please do this slides. What is the significant figures? So now we can check what is the answers. Now we can check. So this is the correct answers. So 3, 4, 4, 1, 2, 5. So this is for the correct answers. So this is for the number of significant figures. That's the correct answers. So next, in case multiplications is there, that time what we can do. So here two decimal here two number is there, and a 28 here also two digital number is there. So both sides same 2. So the answer will come. We can take for two digital number only. First two digital numbers. So here also do 256 two digital, 28 also two digitals. So answer also we can take for only for two digitals. So 15. So 15 and here for 6. So we can take for 1600. So this is the in case multiplication we can do for this type. So 16. This is for the answers 1600. So this is in case multiplications. So now we can see for this here 4833 here 1741 into 1741. So both side 4 digital is possible. So we can take for the answer 4 digital only. So first 4 digitals 8414. So next two less than 5. So we can remove that point. We can remove the 2. So what is the answers? 8414. Remaining 000 is there. So this is for the multiplication methods. So now the division here 5 digital is presence 628815 digital is presence here 2 digital is presence. So we can take for less digital number answers. So this side here both same here also same, but here 5 digital here 2. So 6 4. So what is the 4 near 8? So 6 5. So remaining 000. So 6 5. This is the answer for multiplication or division. This is the answers. So here 4 digital, here 3 digitals. So what is the answers? We can take only an answer for 3 digital. Where is less digital number that we can take for the answer? So 501, nearly 9 is there. So greater than 5. So that's why we can take for 502. Remaining all 000 is there. So this is for the. So here 3 digital, here 2 digitals. We can take for 2 digital the answers. So 8.4 is the correct answers. So here 5 digitals and the 2 is the 1 digitals. So we can take only one digital answers. So what is the one near for 1 less than 5? So that's why we can take for 1000. So this is the answers. And in case 10 to the 10 to the in case 10 to the power is presence, we forget this for this. We forget this only. We consider only for this only. We forget for 10 to the power of 19. No need to this. Only consider this point only for significant figures. 5.42. So 3. So 3 is the correct significant figures. So this no need in 10 to the power of minus 8. That is no need. We consider only for this only. So 7. This is for the 4. What is the 4? And in case the 2.0 into 10 to the power of 12 divided by 10 to the power of 330, sorry, 10.330 into 10 to the power of 8. In case there, this 10 to the power of 12, in case this 10 to the power of 12 divided by 10 to the power, this is 8, we can subtract 10 to the power of 12 minus 10 to the power of 8 is 10 to the power of 4. So where is less digital number? Here 2.0, here 8.330. So more digital number, here less digital number. So what is the answer? Sorry, 10 to the power is decreases when the decimal for moving right side. That time 10 to the power is decreases. So this is the answers. So when decimal is moving for right sides, that time the 10 to the power of is decreases. So this is the answers. So this is also same for adding concept. Both are same 10 to the power of 4, 10 to the power of. So what is the 2.1 and the 9.2? We remove these two digital numbers. So only for 11.3. So when decimal moving for left side, the 10 to the power is increases. Decimal moving right side, that time 10 to the power of 10 to the power decreases. Decimal point moving for left side, that time 10 to the power is 10 to the power is the increases. So this is for the concept. Next, chromatography. Madam, which time? Break time? Break time, madam. Which time? Chromatograph.
Sir, break is required.
No, no, no. No need for myself. But,
We have not planned it. If you
okay.
will, if you want, you please
No,
declare
no,
as per your
no,
convenience, sir.
no problem. No problem. So chromatography is very, very important nowadays. So what is the importance for chromatography? Total molecular probe from this total for nearly for 17 chromatography is there. Um, So, so this is total 17 chromatographies there. So this is for column chromatography. Already you know about the column chromatographies only for scientific problems. It has scientific problems. Some scientists, telling they're saying for the chlorophyll is not a single chlorophyll is single compounds. Some scientists explained, no, 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 chlorophyll is no single, not single compounds. It is multiple compounds. So he has very confused. The Michael Sweat, a Russian botanist. So then he was taken for the column chromatography. The column, this is the column. The column is filled for stationary calcium carbonates powder in petroleum ether. Then for both bottom and the up, they are full cotton. They are put, he put for cotton flood and washing illusion with ethanol, that is for the mobile phase, and a connected solution of chlorophyll in petroleum ether. So that is the analyte compounds chlorophyll in petroleum ethers. So then he added little by little in this the calcium carbonate is stationary phase. So dear faculty members, what is the stationary phase and what is the mobile phase? Any idea? What is the stationary phase and what is the mobile phase? Any idea for stationary phase and mobile phase?
Stationary phase is that it is on which separation takes place, and mobile phase is like a carrier of various mobile phase, either gas in gas color chromatography, liquids in liquid chromatography.
Okay. Any others?
Mobile phase is movable part.
Yeah, yeah. Yes, correct. Any others? Some points. Mm, okay. Stationary phase. Calcium carbonates. That is for very important. This is for adsorbents. Calcium carbonate is the adsorbents. So what is the adsorption and absorptions? Any example? Adsorption and absorptions. Any example?
Sir, adsorption in surface area.
Adsorption takes place in surface. Absorption inside the surface.
Okay. Any example? Not chemistry. For practical in home. Anything for example? Your
Calcium carbonate, chalk,
calcium.
calcium carbonate like chalk, it absorbs. If we
Yeah,
on the
yeah. That
surface,
is.
if we
So
break
I
it,
am asking, what is the adsorption?
this is adsorption. On chalk, there is adsorption, and if we have a ball, sponge
No,
ball,
madam.
and we put it,
Generally, I am asking, what is the adsorption?
So,
it is a surface
uh,
phenomenon.
can I talk,
Generally, I am
sir?
asking, what is the adsorption? So chapati and dosa, chapati and dosa. Chapati, that is for chapati and some sambar or gurma, and dosa or some sambar is there. So which is absorption? It is chapati.
Adsorb.
Adsorb.
Adsorb. Breathe,
Yes,
breathe.
yes, that's no, ma'am, correct. Chapati is absorption. Dosa,
Absorb.
yes. So chapati is for absorption because only surface area that whatever present for sabzi or anything only for surface area. Dosa we can add for sambar. So that is for the absorptions. So absorption and absorptions. In the chromatography techniques, absorption is very important. Absorptions, not for absorptions. Absorption is the very important. So calcium carbonate is a good absorbent. So calcium carbonate is the good adsorbents. So here, uh, when he did that, he did these experiments. surprise. So the chlorophyll total for five different compound coming, five different compounds, elevates, carotene, and violozanthine, and xanthophile, and alpha chlorophyll, and the beta chlorophylls. So different five compound colors, five different color appears on the absorbent of calcium carbonate backgrounds. So the white color changed for colored. So the so different color, five color is appear. So what is the chromatography? Chromo means color, graphy means written. So that is for the chromatography. So madam, why carotene is coming very fast down? Among the five compound in the presence of chlorophyll, but the carotene is very fast coming down, elevates. So what is the reason?
Non-polar, both non-polar. And
Yeah,
retention one, RF vector is
so guys, what is the interactions? Already we know because we are chemistry faculty. So polar is more interactions, and non-polar that is for more interactions. Polar more interactions, and non-polar is more interactions. So here, so what is the interactions? Calcium carbonate is presence. So here, uh, so uh, so here, interaction is there. Interaction is occurs. Polar and the non-polar interaction is occurs. So in case the stationary space is polar and the compound also polar. So polar more interactions. It's come for very late because of more interactions. So it's come for very late. In case non-polar and the stationary phase polar, so non-polar is coming down very fast, elevate is very fast. So this point is very important in all technical chromatography, GC, HPLC, and all chromatography. Polar interactions and the non-polar interactions. Polar is more interactions, and the non-polar is more interactions. So that's why this is the reasons. So now we can see the runners, but after runners running on the grounds, they are separating 1, 2, 3, 4, 5. So what is the reason in the grounds? So what is the reason they are separating difference? So dear
Due,
faculty members,
due
here
to different affinity.
no need for
Affinity towards.
chemistry. Here no need for chemistry.
resistance is there. More resistance,
No,
so less mobility.
no. Here no need for chemistry. Generally, I am asking why they are separating here. All are standing same distance.
Their running capacity.
Running capacity means what is the rate? Rate.
Running rate, yes.
Rate means running. Running is not rate. How you are saying car or bus, anything running, moving with
Low
the
and fast
speed. That is for
speed,
speed.
yes. It is
So
speed.
here rate is the speed. So different that among the five members, they are different speed. So that is called for degree of speed. So here rate, what is the rate? Degree of speed. So here, what is the different degree of absorptions? So each compound is different absorptions. So that's why we call for that is called for degree of absorptions. So both all the five compound the different absorption on the calcium carbonates. So that's why this is called for degree of absorptions. So here where speed or velocity, here rate, speed or velocity is very important. So this is the reasons, different absorptions of the components, five component different absorptions. This is called for degree of absorptions. So now rate theory. So what is the rate theory? The rate theory describes shape and width of the chromatographic band based on random walk mechanism for the migration of molecule through the columns. So what is the rate theory? Is able to explain effect of mobile phase velocity. This is very important. Mobile phase velocity and the absorption capacity of stationary phase. So this only may of rate theory. the velocity of mobile phase, and absorption capacity of stationary phase. This is the very important for rate theory. So, what is the rate theory? The rate theory is able to explain the effect of mobile phase velocity and the absorption capacity of stationary phase, which determine the width of band peak. So, this is the determined width of the band peak. So, rate theory is very important in the chromatography. It shows relationship between mobile phase velocity and the absorption capacity of stationary phase. The absorption capacity of stationary phase with retention time of the solids. So what is the migration of solid molecules in column occurs? So keep in our mind, stop and go sequence. This is very important. Stop and go means when it is present in mobile phase, that is for go. Stop and go. So the migration of solid molecules in column occurs stop and go sequence. So this is for the rate theory. So here two loose and large particle is present. The particle is two loose and large particles. Here two tight and a small particle is present. So two tight and a small particle is present. Here two loose and large particles, two tight and small in the column.
Smaller particles.
Which is best in the column? Which one is
Smaller
best?
particles, sir.
Okay. Large particles not good, ma'am.
Yes, because they did not provide good separation in terms of smaller particles.
Any idea others? Okay, your point is correct, ma'am. Correct. Your point is very correct. Any other give some ideas? Why too loose and a large particle is not good, not efficient? The too tight and the small particle is very efficient. Any idea?
Surface area,
What, madam?
surface area, but
Yeah,
increases.
surface area is one of the good answers. Correct. Any other points? I need for other points. I want for other points.
Surface to absorb increases. Breaking tight
Good resistance. It provides good resistance.
Oh, resistance. Okay, resistance is okay. That is okay. So okay, I will
Smaller
explain. No
particle.
problem.
In a smaller
Yeah, here
particle, the
two.
pressure.
Yeah. Here two tight and small particles. That is for more interactions. More interactions. Here for less interactions. The analyte compound less interactions. So which is more separation? Something the sound was coming voice. Rasmi, 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 Rasmi Dagur. Rasmi Dagur.
Excuse me, Rashmi ma'am. Hello, Rashmi ma'am, please. You are disturbing the session, Rashmi ma'am. Please mute yourself, Rashmi. She is not listening. Rashmi, please mute yourself.
Hello, ma'am. Host can also mute them. You can directly mute them.
Okay, madam. No problem. So here, very two loose and large particle, the interaction is very less. The analyte particle interaction less for stationary phase. So the F is the separation is not that much efficient. So here two tight and small particles interactions, more interaction for analyte and stationary phase. Analyte and stationary phase, that is for more interactions. So the separation is very efficient. It will come for a very efficient. So the two tight and small particles, the column filled two tight and the small particles very important. So which one is surface area more, large particles or small particles? Surface area, which one is very more? Which one is more surface area, large particles or small particles? Surface area.
Small particle.
Yeah, yes. Small particles. When grind the powder for the crystal particles, that time the surface area is increases. That's why we can do all time the grindings. Why we are doing for grinding? Because of the increase of surface area. That is very important. So, so this is for our department, our lab. This is my lab for GC gas chromatography instruments. So this is for the data analysis. This is for the oxygen, the hydrocarbon, and the moisture trap. This is for oxygen, moisture, the hydrocarbon trap. So this is for UPS. This is for UPS. So what UPS means? Because already you know GC temperature controlling programs. GC running for temperature controlling programs. When power suddenly cut, that time column is damaged. Column will occur for damage. So the column nearly for 45,000 or 50 to 50,000. So that's why we can need for UPS. So when UPS is present, that time column cooling, then we can shut down. Otherwise, without UPS, we cannot run for GC. In case suddenly power cut, our column, our column will occur for damage. So our column, capillary column, we can use for organic compound analysis. So the column price nearly for 40,000 or 50,000. So very careful we can run the GC instruments. So now this is for the cylinder, hydrogen, nitrogen, air. Any please explain anyone why we are using for gas? Any faculty members? Why we are using for three gas cylinder? Any idea?
Carrier gas.
Yes.
So nitrogen is a carrier gas.
Yes, madam.
Hydrogen is used for combustion.
Yeah. Yes. Okay. So here this is not air, zero air we can use for zero air.
Zero air is oxygen.
Oxygen we can say oxygen. Why we can say for zero air?
I think it is
Moisture free.
9.999% pure.
Okay, I will explain, ma'am, no problem. So this is for the carrier gas should be high purity, minimum 99.995%. And so this is carrier gas should be high purity. Oxygen and water impurities can chemically attack the liquid phase of the column and destroy it. So trace water content can dissolve other column contaminants and produce high detector background. Trace hydrocarbon contents can cause high detector background with FID and limit its detectability. So this is for the main purpose. So carrier gas. Why? What is the main purpose? Carries the sample through the column. Carries the sample through the column. So that is for the main purpose. So why carrier gas? What is the main purpose? Carries the sample through the column. That is for the main purpose. And what is the secondary purpose? What is the secondary purpose? Provides a suitable matrix for the detector to measure the sample components. So different type of detector is in GC is there. In case we can use for thermal conductivity detectors. So what we carrier gas we can use for helium, because of helium is high thermal conductivity. That's why in case we are using for thermal conductivity detector in GC, the carrier gas we should use for helium, because of helium is high thermal conductivity. So that's why a detector for thermal conductivity what kind of carrier gas we can use? Helium. And the flame ionization we are using for flame ionization detector in GC, that time helium or nitrogen we can use. Because of why helium we are not using? Helium is already helium very costly, so that's why nitrogen very cheap, and flow rate also nitrogen is very less, and helium flow rate is very high. That's why flame ionization detectors mostly we can run for nitrogen as a carrier gas, and electron capture detectors very dry nitrogens on or argon and the 5% methane we can use for carrier gas. So hydrogen, nitrogen, helium, and argon are normally or interactive gases. CO2, NGS3, steam, and CO and CS2 vapor, and the formamide vapor also used for GC under certain desired conditions. So we can use for this. For better column performance, one must choose for column chromatography with smaller diffusion coefficients and higher molecular weight. Nitrogen, argon, and CO2 give for lower flow rate than for hydrogen and helium. And viscosity is essentials dictate the gas pressure is required. So next, hydrogen has a higher diffusivity than for helium. Specifically, under isothermal conditions, the linear velocity for hydrogen is 40 centimeter per second. So hydrogen also we can do for carrier gas, but 40 isothermal conditions, the linear velocity for hydrogen is 40 centimeter per second. So which is twice that of the helium, 20 centimeter per second on the short time analysis. The choice of carrier gas TCD is helium. So TCD means thermal conductivity detector is helium because of its high thermal conductivity. However, because of its high thermal conductivity, that's why the thermal conductivity detectors we can use for carrier gas helium. However, nitrogen, hydrogen, argon also used. The TCD works best when there is a large difference thermal conductivity between gas chromatography and the samples. TCD can detect, thermal conductivity detectors can detect air, hydrogen, nitrogen, sulfur dioxide, inorganic gas, and many other compounds. Nitrogen or argon can be used for the analysis of hydrogen or helium, but greatly reduces sensitivity for other compounds. So this is for the moisture trap. So the cylinder inputs here, the gas inputs, here gas is outputs, input and outputs. This the middle part is the what is the presence moisture trap and hydrocarbon trap and moisture trap, oxygen trap, moisture trap, and hydrocarbon trap is present. So why the hydrocarbon trap is present and oxygen trap is present? Why this is for silica gel? All the is for silica gel. So why we are using for this trap? Why we are using this trap? Any idea? Dear faculty members, any idea why we are using for this trap, different kind of trap, moisture trap, oxygen trap, and the hydrocarbon trap? Any idea why we are using for trap or moisture? It will react with for analyte compounds. So that's why the separation is very difficult. So the limitation is occurs. That's why we can do for the trap, moisture trap is we can using. So what is the difference between zero air and the oxygens? The main difference between atmospheric air and the zero air is that zero air contains much lesser impurities contents of water vapor. The zero air contains much lesser impurity contents of water vapor and hydrocarbon than for atmospheric gas. So this is called for zero air. So zero air contains much lesser impurity contents of water vapor and the hydrocarbons than for atmospheric air. The zero air is produced by pure nitrogen and pure oxygen in a controlled quantity composition under controlled atmospheres. So this is for the zero air. So this is different for zero air. And this is for the GC, the inside ports. GC, the inside port. This is for inlet connections. The column inlet connections. This is for the detector connections. This part is detector. This part is injector ports. So injector port, this column. So this is for the capillary columns. And the inlet connection column size nearly 4 to 5 mm. And the detector connection column size 47 mm. So this is for the detector connection column size and the inlet connection column size. This is the connections. So this is for the GC upper layer ports, top layer ports. The top layer port. This here is TCD column, temperature conductivity detector. Detector is present here. Here FID, flame ionization detector is present here. Here for this is called for electrometers. Here collector the rod here is present. This is the top layer. So this is for carrier gas injection port. So this part is injector ports. The carrier gas connect with the injector ports. And the detector ports. Detector port, three gases connected for detector ports. So this what kind of detector? Flame ionization detectors. Here hydrogen present and nitrogen is present and air is present. So here three gas is present connected with the detectors. Here injector port only one carrier gas, only nitrogen is only present. So what is the role of carrier gas? Dear faculty members, what is the role of carrier gas? What is the role of carrier gas?
Carries the sample to the destination.
What, ma'am? Yes, ma'am, please. Nina.
Sample, yes, sir. The sample injected is carried.
Yeah, sample carries through the column.
Yeah.
The what is the carrier gas role? Because sample not possible. So that's why we can do for carrier gas. Then doing for carrier gas, that time that analyte take through the columns, the sample through the columns, then reach the detectors, then reach for detectors. Yes, correct. So that's why we can do for the so this part is the injector ports, liner, the ports. What is the usefulness of GC? Very easy and very fast and very reliable and very rugged, both qualitative and quantitative analysis for volatile samples up to about 250 degrees Celsius and 0.1 to 1 microliter of liquid or 1 to 10 ml of vapor can detect less than 1 ppm with certain detectors, can be easily automated for injection in data analysis. So GC, so here mobile face, madam, here what kind of properties need for mobile face? What kind of properties need?
Should not react with the sample, and it should be
What, ma'am?
inert. It should be inert in nature.
Yes, ma'am. Very good. Correct. Your answer is very correct. Mobile phase is chemically inert. So that kind of gas we can use. So oxygen we cannot do for carrier gas. Why oxygen we cannot do for carrier gas? Oxygen.
Yeah. Highly reactive, it will oxidize the thing.
Yeah, oxygen react with analyte compounds. So oxygen react with for analyte. Oxygen is not chemically inert. So so that's why oxygen we cannot do for carrier gas because of oxygen react with analytes. So that's why we cannot do for carrier gas for oxygens. So nitrogen is chemically inert, so we can do for carrier gas for the nitrogens. So this is for the carrier gas. So which one is mobile phase here? Darsana ma'am is not coming.
Yes, sir. I'm here.
Which one is mobile phase you are using?
Helium.
Yes, which one is mobile phase in GC?
Helium.
No. Mobile phase,
What?
which one is mobile phase in GC?
Okay. Are you want a definition?
No, okay. Definition is what which in GC, what is the mobile phase and what is the stationary phase?
Okay.
Both are present in GC. Yeah. Which is mobile phase? Which one
It
is
is the
mobile phase?
carrier gas.
Yeah.
Carrier gas.
Carrier
Yes.
gas. Carrier gas.
Carrier gas is the mobile phase.
Mobile phase.
And the column that is for the stationary phase.
Capillary
Carrier gas is the
column.
mobile phase, and the column that is for the stationary phase. So column, I will explain about the column. So here mobile phase. So what is the mobile phase? Carrier gas is the mobile phase. So here the mobile phase does not interact with the molecule of the analytes. That is very important. The mobile phase does not interact with the molecule of the analytes. Its only function is transport the analyte through the column. So keep in your minds, this is very important points. The mobile phase does not interact with the molecule of the analytes. Its only function is to transport the analyte through the column. So the rate of the movement of analyte is largely independent of the chemical nature of the mobile phase. So the principal intermolecular forces that occurs between solid and solvent so are dispersion, induction, orientation, and the donor acceptor interactions. So what types of sample can be analyzed by GC? So gases, vapors, or any substance that can be volatilized without decomposition and with reproducible decomposition or converted into volatile derivatives. So this is for the okay. So next, gas advantage and disadvantage. So hydrogens. So hydrogen is cheap but can form for explosive mixture with the air. So hydrogen cheap but can form explosive mixture with the air. So that is for the disadvantage of hydrogens. And the helium very inert and the efficient separation and non-inflammable. So what is the disadvantage? Expensive. That is the disadvantage. Nitrogen. What is the advantage? Cheap. Very inert, will not react with the analytes and non-inflammables. And what is the disadvantage? Very slow velocity to achieve for good efficiency. So that's why the nitrogen we can use for carrier gas. That's why nitrogen we can use for carrier gas. And the ovens. And this part is very important, column over. Isothermal process. What is the isothermal process? Run at one constant temperatures. That is for the isothermal process. The temperature programming start at the low temperature and gradually ramp to higher temperatures. So start at a low temperature and gradually ramp to higher temperatures. So why start at a low temperature and gradually ramp to higher temperatures? Because we can set for the temperature programs 5 degree per minute, 5 degree per minute, or 100 degree per minute is good temperature program. So which one is good?
Five tick.
Class fighters, sir, the MP Madhya Pradesh. So which is best? Madam, temperature programming 5 degree per minute. So nearly 250 degree maximum temperature 300 degrees Celsius. We can use for 300 degrees Celsius. But the temperature program we can set 5 degree per minute is good or 100 degree per minute is good.
Only then we can separate efficiently.
Yes, madam. Yes, correct. Your answer is very clearly correct. So efficient separations. So 5 degree per minute, that is for efficient separations. When we are put 50 degree per minute, that time the separation is not efficient. So separation very poor efficient will come. Yeah, very correct answers. That is. So the temperature program is very important. Start at the low temperature and gradually ramp to higher temperatures. That is very important. And the more constant peak with better sensitivity for components that are retained longer, much better chromatography resolution, and the peak refocusing at the head of the columns. So what factors affect the separation? Boiling point of components in sample. Low boiling point increases as molecular weight increases. The flow rate, next importance. Madam, flow rate also. 50 ml flow rates and 2 ml per minutes. 50 ml per minutes flow rate, gas flow rate. I am asking for gas flow rate, which is good flow rate. So more flow rate is good or low flow rate is good for gas?
Low flow rate. Flow rate.
Low flow rate is good or more flow rate? Why
We are
low flow rate
confused.
is good? Why low flow rate gas is good?
High flow rate should be.
High
So
flow
that
rate is
it makes
good, ma'am.
yes, it should high flow rate for the gas, carrier gas.
So that is good.
Uh,
Kettle, ma'am.
that is
Kettle, ma'am.
that is good, I think.
Okay, madam, no problem. So kettle, ma'am, not saying any answers. The others, total nearly 50 faculties presents, but only one ma'am is giving the answers.
Yes, sir.
Okay. So which flow rate is low flow rate is good for gas or high flow rate is good?
Low flow rate, sir.
Why, ma'am? Why? Yeah, that is okay. So high flow rate.
So high flow rate, in that case, the peak is eluted within few minutes. I think
Yeah,
within
yes,
1 or 2 or 3 minutes.
So less interactions. When flow rate is high, that time less interactions because
Yes.
the analyte compound elevate very fast and the interaction also very less and the poor efficiency. Yes, correct, ma'am. Yes, correct. So column length, small length is better or higher length is better? Column length.
Higher length, higher.
Why higher length
Higher
is better? Column length.
so that more space for the separation, more
Yeah, more interactions.
yes,
Longer column, more interaction, and very separation is very good efficiency. Yeah, that is correct. Column length increase, efficiency also increase. Column length less, efficiency also less. So column length also very important. Yes, ma'am. Very good. Column length also very important. So this is calculated for the area. Speed of the chart paper is 2 centimeter per second. So this is for the peak A and the peak B. So peak A nearly for so peak A. So this is for unretained peak, that is for 2 centimeters. So peak A is 6.5 centimeter and the unretained peak, that is for 2 centimeters. So peak A, how calculate? 6.5 centimeter divided by 2 centimeter. So this is for unretained species. This is for peak A. So this is the retention time. Calculate the retention time, 3.25 seconds. So peak B, 13.4 centimeter. This is unretained species. So total for 6.7 seconds for retention time. And how calculate for area? How calculate for the area? So area calculate for height, the peak height and the half of width, and the half of width, W1 by 2, that is for half of width and the peak height. This we have these, we find out these two, what is the peak height and what is the half of width. So peak height into half of width, that is for the area of the peak area. So what is the height? 28.2 mm into 3 mm, so into 98.7 mm square, that is for the peak A area, and the peak B area 41.2 mm into 4. What is the half of it? 4.5 mm. So this is for peak B. So next for gas distance, what is the retention time? The time required for compound to pass through the column. So what is the retention time? Distance from the injection point divided by speed of the chart recorders. That is for the retention time. So this is for the classification of methods: gas chromatography and liquid chromatography. So gas chromatography, what is the specific method? Two method is present: gas liquid chromatography or gas solid chromatography. So this is for the gas chromatography. Two method is present. And what is the stationary phase? First method, liquid adsorbed or bonded to a solid surface. So that is for the first method. So next type of equilibriums, the partition between gas and the liquids. So the partition between gas and the liquid, equilibrium is occurs between for gas and the liquids. So where is the gas is present? So gas is present for mobile phase. Where is the liquid is present? Stationary phase. Here column is solid coated for liquids. So here present column is liquids. So column here presents solid coated for liquids. So here column is liquid column we can use for liquid GC. So that's why the equilibrium is partition between gas and liquids. And the gas solid, that is for stationary phase solid, and the adsorption occurs. Liquid chromatography, total 5 method: liquid or partition or liquid solid or liquid or adsorptions, ion exchange, size exclusion and affinity. So this is for the stationary phase we can use. And chromatography terminology, what is the chromatography terminology? Stationary phase is confined in a column or on a plate or paper. Element column, elevate outs. Element in column and elevate outs. This process is called for elution. This process is called for elutions. So column or either packed the thick layers. What is the blue color? What is the blue? That is for stationary phase. So 1 micrometer thick layer for stationary phase. So this is for the column. And migration of analytes in a column. So rate of migration of analyte to the column depends on the equilibrium of the analyte between stationary phase and the mobile phase. So very important. The migration of analytes, the rate of migration of analyte through a column depends on the equilibrium of the analyte between stationary phase and the mobile phase. So that is also very important. And what is the distribution constant? Concentration of analyte in a stationary phase and the concentration of analyte in a mobile phase. This is called for distribution constants. So retention time, the length of time from sample injection until the analyte reaches the detectors. The length of time from sample injection until the analyte reaches the detectors. So this is for the dead time. What is the dead time? The length of time unretained species to pass through the column. Unretained species to pass through the column. That is for the dead time. And the adjusted retention time, actual time the analyte is retained on the columns. So that is for the adjusted retention time. That is called for the adjusted retention time. So retention time is different. and adjusted retention time is difference. So next for the increase resolution by increase n. What is the n? N is number of theoretical plates. So n means number of theoretical plates. If your number of column length is more, n and the resolution is increase. So the increased resolution by increasing gamma, that is for unadjusted relative retention time.
Excuse me.
So okay,
Okay.
ma'am.
Okay.
Slides.
Okay. Now it's okay.
Now okay, ma'am. Okay.
Yeah. Yes, sir.
Okay.
Yes, sir.
Okay. Okay. Sorry. So this is for the chromatography okay, terminology. So this is for the column wall. This is for the inner diameter. The blue color, that is for the stationary phase thick layer, 1 micrometer thick layers. And this is for distribution constant. The concentration of analyte in a stationary phase and concentration of analyte in mobile phase, that is for the okay. So this is for the more n. N means theoretical plates. The intensity of peak is very high. The one deemed equations tell us how column type and flow rate affect the plate kinds. So this is H equal to A plus B by mu x plus C mu x equal to multiple paths on the longitudinal diffusions and the equilibrium time. So this is for the one divided equations. So nowadays the column self no need for a banner. Nowadays the self tightening column heads will come. So this is we can use less wasted times. So easy of use and a leak free lower column bleeds, that is okay. So this is for the column. This is for the support coated columns. The handle larger sample quantities. Supported coated columns can handle larger sample quantities. So this is for the wall coated columns. So this is for the wall coated columns. So this type of column is wall coated open tubular column, WCOT, wall coated open tubular column. So this is for supported coated open tubular column. So this is for SCOT column. So the solid support coated with stationary liquid phase. So okay, this is very important. Solid support coated with stationary liquid phase. So in GC we can use for liquid phase, stationary phase. Solid support coated with stationary liquid phase. You can use this column. So stationary liquid phase. In GC we can use for stationary liquid phase columns. So here porous layer open tubular column. So WCOT, what is this kind of column is wall coated open tubular column. So this kind of column is supported coated open tubular column. So this is column porous layer open tubular columns. So supported coated columns can handle larger sample quantities than wall coated columns because of higher surface area of liquid on the supports. In porous layer columns, the solid is the stationary phase. So this is for the non-polar and weak intermediate polarity and strong intermediate polarity and strongly polar polyhydroxy alcohols, amino alcohols, hydroxy acids and polyprotic acids and polyphenols. This is for strongly polar and non-polars. Already we know saturated hydrocarbons, the hydrocarbons, saturated hydrocarbons, the polyphenic hydrocarbons, and aromatic hydrocarbons, the halocarbons, mercaptans, sulfides. This is for the non-polar compounds. So, dear faculty members, this how we can analyze in GC. These plans, how we can analyze in GC. Any idea? Any idea how we can analyze GC? This plant. Ajit Joshi.
Ajit sir. Ajit sir.
Ajit
Are you
sir.
here? Ajit Joshi.
He is not present.
I think he is not present. Ajit sir.
Anu Dakur. Anu Dakur, Padanya. Ma'am, most of the faculty what doing?
Anu? Anu
What
ma'am? Anu Thakur?
Sir, hello.
Hello?
Sir,
Huh.
hello, sir.
Sir, Ranveer Singh is here.
So,
Hello.
yeah, yes.
Sir, yes, sir.
So this
Sir,
kind
I
of
think,
plants, how we can
yes, sir.
analyze this in GC?
Yes, sir. I think that the abstract of this plant, column chromatograph, then we separate the components.
No, no. What I am asking, GC, gas chromatography. Don't go for column chromatography.
Yeah,
I am asking only for gas chromatography.
gas chromatography.
Yeah.
Head space GC.
After extraction, sir,
Yeah.
we can utilizing this thing
Yes.
with this.
Yes. Extraction is very good. So we can do for extractions. Then dissolve with in case dissolve with the solvent, we can do for otherwise so insoluble with solvent, we can do for gas form, heated for thermal heated, then gas form, then that the gas injector is there that we can inject. So soluble, in case soluble, we can do for liquid form. Otherwise, this is not soluble with a solvent, so we can do for gas form. Then we can do for the gas form. So I will explain the problems. So extraction is very important. This is we can do for extractions. So this is for caffeine. How this sample we can analyze caffeine? So that is for extractions, no problem. So this is for caffeine. How we can analyze this in GC? Gas chromatography. Any idea? So we can do for gas form. So this is for caffeine. Some heating process we can do for the head phase. This is for head phase injector. We can use for head phase injector. So so when the upper layer, this gas only we can inject. We can take through the gas injector, then inject with the gas GC. We can analyze what type of compound is present. So with the solid is not soluble with the solvent, then we can take for gas form. So the head phase we can take for the gas inject the gas injector. Then we inject the gas chromatography. We can analyze accurately what kind of sample is present in the caffeine. Okay. So this is for core. Inside the gas is this gas is evolving. So this gas also we can detect what kind of gas is in the inside the core is present. Inside the core, what kind of gas is present? We can detect because of we can detect for head phase. What is the head phase? The gas is inject the gas phase. Inject the gas. The gas injector we can do that. Not normal injector. The gas injector is available that we can inject for the head phase, then inject for GC. We can detect what kind of gas is present in the columns. So petroleum and the chemical products, the environmental and the food safety, drugs and the drug development they can use. So gas, natural gas, petroleum gas, inert gas, and air quality, and the landfill gases. This is under solid form, liquid form solvents, gasoline, alcohols, pesticides, glycols we can detect. And the solid solvents from tablet and the head phase samples, trace solid dissolved in solvent and pyrolyzed coal or cell oils. So this is for manual injectors. So liquid are typically injected by 5 to 10 microliter syringes. So this is for 5 to 10 microliter we can use for manual. This is the manual injectors. Nowadays the industrial, because university no need for manual automated injectors, that is very costly. So that's why we can so we can only for doing for manual injectors. That is because rate is very cheap, 13 lakhs. Automated is very important in industrial, 24 hours running. So that is the important for automated injectors. No need for university or colleges. This is very enough. So this is for the gas injectors. This is for the gas injectors, head face gas injectors. I can detect instruments. This is for the automated injectors. So the fill all the sample filled with this in the pots in the pots fill all the samples 24 hours. The GC samples run at the 24 hours. So next days we can fill, then run at the 24 hours. This is for the automated. In gas chromatography is nothing. So what is the point one? What is the point one?
Carrier gas.
Yes, point two. Point two. Two. Second point. What is the second point?
Injector.
Injector. Third point. Third.
Column oven. Column oven.
Column oven is this here. This is the oven.
Yes.
So the
Detection.
column. First part is carrier gas. Second part is injector part. Third part is column part. Fourth part is detector part. Fifth part is data analysis. So only 5 part is present in the GC. So first part is carrier gas. So what is the we can helium, hydrogen, argon we can use. So high PUD 99.995%. This is for Agilent technology. Our instrument for Agilent technology. So I can take this all the slide from Agilent technology. So carrier gas should be chemically inert, should be cheap and readily available, should be highly quality, not cause any fire accidents, should give best possible results. So this is for the carrier gas. So hydrogen, helium, and nitrogens. So hydrogen fastest, helium middle fast, hydrogen is slowest, and cheap. Nitrogen also very cheap. So this is the column. This is the column. So the sample is separate. Analyte is separate. So how many compound is present? 3 compound is present. The blue, green, and red. So the analyte, the column separated the analyte. So what is the principle? Based affinity. Affinity means solubility in the stationary phase. This is one of the principle. And the second principle, boiling points. So affinity and the boiling points. This is the principle of gas chromatography. So what is the affinity? This sample. This is for liner. This is called for liner. So this is called for sample column. So when inject the sample through the liner, then coming through the column, and the column separated or separate the analytes, then exit the detectors. The detector find out the what kind of the sample is present. So column selection principle: choose stationary phase and the column diameter and the film thickness and the column length. This is very important. So this part is the syringe part. Syringe part. So we can very little amount of we can inject. Now don't do so much amount. Very little amount of sample we can inject. So what is the range? 0.2 to 3 microliters. 0.2 to 3 microliters inject the sample through the GC columns. So when inject less concentration, that time we can take this peak. Injected less sample, we can take this the peak coming out this peak. When inject large sample, when inject the peak coming this type of peak will come. So that's why injection sample is very less amount. So same column and the same chromatographic conditions. So this is for short concentrated. So the intensity peak is very sharp. This is long diffuse. So that's why the peak with a broad band peak will appear. So this is septum. So this is for injector, this is for liner, this is for septum. Why we are using septum? Because outside atmospheric air is prevents not coming the insides. That's why we are using for septum. So this is when injector sample. This is the liquid sample. So this is for septum. This is called for liner. That orange color, that is for the liquid sample. So when liquid sample, when because we can set the temperature for 250 degrees Celsius. So now this liquid sample, what can be converted? Now the liquid sample, what can be converted? Madam, what converted?
High temperature,
The liquid sample.
boiling point of the.
Yeah. Maximum point is 2 degrees Celsius we can use. So when injected the liquid sample, now the liquid sample, what can be converted?
Into gas phase.
Temperature using what, 2 degrees Celsius. The liquid is converted to gas. The liquid sample converted to gas. See, now here liquid is present. Now the liquid sample converted to gas, vapor, volatile. This is volatile. So this volatile is vapor is injected through the columns. So the liquid is converted to vapor or volatile. Then the volatile is enter the columns. Enter the column. How enter the column? Because through the carrier gas. Through the carrier gas, this then column separate the analytes, and the analyte can reach the detectors, and the detector find out so what kind of the sample is present. So this is for the column. The third part is column is presence. So this is the column. So in that very small length, very small, very thin. The column is very thin, but how many layer is coated? See, 1, 2, 3. Total 3 layer is coated. The top layer is polymer. The second, the yellow color is fused silica. The orange color is that is for the liquid phase, stationary phase. So total 3 layer is present. The top, bottom layer is polymer, polyamides. Why? Because of the to increase the mechanical strength. That's why we are coated the top layer for polyamides. Polyamides. The yellow color, that is for the silica, fused silica. Yellow color is fused silica. Then the inside that layer is very important. That is for the stationary phase, liquid stationary phase. So all the analyte sample interact with that is stationary phase. So this is for the polyamide, the top layer, that is for the polyamides. So this is for the polymer coating. This is for the fused silica, and this is for inside this layer is liquid phase. So what is the thickness of the 0.5 to 5 micrometers? That is for the thick films. So this micro greater than 1 micrometer. What is the advantage? Increased retention for volatiles and increased capacity. So what is this? This thick films. So greater than the thick film is very more less efficient. Disadvantage, less efficient. And the high temperature is very important because of less than 0.5 micrometers. That is for highest efficiency and lower elution temperature and fast analysis. So this is also very important. So what kind of stationary phase we can use? DB1 methyl silicone, that is for stationary phase, and phenyl methyl silicone, that is DB5 5%, and DB1701 and DB bats. So in case our sample hydrocarbon is present, we can use for DB1 methyl silicone. In case alkaloids drugs present, we can change for the stationary phase column. What column is phenyl methyl silicone? In case alcohol and the herbicides, pesticide is there, we can use for DB1 1701 column. That column is that stationary phase we can use. In case alcohol, glycols and aromatic is present, that is for DB backs. This is for polar column. So non-polar column. This is for slightly polar column. This is intermediates. This is for polar column. Temperature range. So this is for temperature range used for 60 to 325 for DP1 methyl silicate. So for dB wax, most we are using for dB wax columns. So nearly 42 to 40 columns. So this is for the stationary phase. This is called for the stationary phase. So madam, stationary phase is liquid or solid? Stationary phase is liquid or solid? Munir Ahmad, Munir Ahmad, Munir Ahmad.
Hello.
Okay, Mayuri,
Mayuri? Mayuri?
Mayuri.
Mayuri, you are here?
Sir, I think she's not. Mayuri?
Okay, no problem. Okay, no problem. So this is for the our GC instrument columns. So this is the capillary columns. So see how much this is the capillary columns. But this capillary column, three layer is coated. The top layer is polyamide because of increase the mechanical strength, and the middle layer is fused silica, and the inner layer is stationary phase. So total three layer is present in this column. This is for capillary columns. So two type of column is present. This is for the capillary column. So this column is present for packed columns. This is for in case we can analysis for gas. That time we can use for packed columns. So capillary, most of the GC used for capillary columns. So this is for the packed columns. This column we called for the packed column. This is for the capillary columns. So mobile phase, when this is the higher flow rates, and this is for the packed column. Packed column is two layers. The upper layer is stationary phase, and the inner layer is solid supports. So packed column is two layer. Capillary column is three layer is present, and the packed column is two layer is present. So this is for stationary phase. This is for the solid supports. So this is for the separation of fixed gases. So this column we can use for separation of fixed gases. Madam, these two GC is present. So this is for packed column. So slide is visible, ma'am.
Yes, sir. Visible.
So two GC is present. Which one is packed column? Which one is packed column, and which one is capillary column?
At the right side?
This is what type of column?
Sir, first is the packed
Yeah.
column and second is the capillary columm.
Right side?
Right side
Yes.
is the packed
So
and
this
then
is for
left is
packed
the
column.
capillary.
This is yes, correct. So this is for length of the capillary column, packed column, and the capillary columns. So next, packed column or capillary columns. Packed column is low resolutions and a small number of components. Capillary column is high resolutions and multi-component analysis. That is for difference. So injection. So this is for the column separations. So column is this is why the blue color elevate fast. Madam, why the blue component elevate fast, very
Sir,
fast?
due to less affinity.
Two reasons is there, ma'am. What is the principle? Two reasons.
Low temperature.
Yeah, boiling points, low boiling points. So low boiling point is enter first. In case the component different boiling point, so low boiling point is enter first. In case the boiling point nearly same, that time affinity is we can do for the affinity. So that time, so this is for the detectors. When inject the detectors, so detector the point is so GC detectors we can use. So next so this is for the split and splitless injection is so retention time qualitative. So retention time we can analysis for qualitative. This parameter used for identify sample components, qualitative. Peak area or height, quantitative. So GC used for quantitative and qualitatives. Returns on time, these parameter used for qualitative, and the peak area or height, these parameter used for quantitatives. So that this parameter used for measure the amount of sample components. So this is for the split components. When we inject for high sample, that time 3 ml, the this is for pulse, the pulse, this is for pulse gases, this is vent. So 3 ml, when 3 ml going this side, so 100 ml, so only 1 ml enter this columns. So this column is called for split columns, split ratio column, 100 is to 1. So this is for the 100 is to 1. When one part goes onto the columns, so remaining went out. So only one part is goes to out to the column. So under splitless injections. So what is the splitless injections? 3 ml per minute pass. The sample remain with the liner for longer. So this is before entering the column due to the lower flow rates. So split and splitless. Split means ideal. This is for ideal. It depends on the concentration of your desired analyte with your samples. So this is for split. This is for the splitless. So in the sensitivity of your detectors, the split injection is ideal, and the split in the reduces adverse interactions. Most of your sample is vented. So this is for a used for splitless injection. So the splitless, the stress analysis, this is for the splitless. So analyze the, so here what happening, the splitless two type occurs. The splitless injector, so we can what happening, absorption and breakdown happening. That's why the intensity of the peak is very broad peaks is appears for splitless injections. So this analyte band is very because of absorption and the breakdowns. That's why the peak is very broad bands. So more volatile analytes. That's why the analyte band is very broad. So resulting the wider peaks. So that is all. This is for the this is when the clockwise we can remove for anti-clockwise the first little this one the little move the anti-clockwise then the septum is process or not no need for washing process. Madam, liner is possible for washing process or no need? Liner is washing process need or no need?
No need, I think.
Why, ma'am? We can inject so many samples in JC,
It's needed.
so that's so no need for washing process. So need for washing process, ma'am, with a solvent. Then keep it oven, dried. Then as usual we can set up. So this we can use for tool. No hand we can use. We cannot use for hand. We can use for only tool. So remove this washed with acetone and keep it oven 100 degrees Celsius. So all the then again we put this liner, the injector pots. So in case column we can change, take this column where this type of we can remove this column, then we can exchange the column another columns. So this is very bad. The column is this is the good. So the column sharp is very good. The column top layer is very sharp. That is very good. This crack, in case the cracking is there, that is the very bad. So very poor efficiency column. So this is for the capillary columns. So this is packed column. This is for the capillary columns. So packed column 1.5 to 10 meter long and 2 to 4 mm diameter is used. So this is for the capillary, and less than 1, that is for capillary column. So less than 1 inner diameter, that is called for the capillary columns, and 0.32 that is for narrow column. So 0.25 that is narrow column, and 0.18 is mini pore column, and 0.05 to 0.10 that is for micro pore columns. So different type of column. This is for the column length. So this is we can use for the, so most common stationary phase used for carbovax. So keep in your mind, this is very important. Carbovax 20, this is 20M polyethylene glycol. So this is for the polymethyl silicon and the methyl esters we can use. So without, you see, without stationary phase, the analyte is no interactions. Here fused silica is only presence, but inside the stationary phase is not presence. So the analyte is no interaction, not interaction with the fused silica. So this is for degradation. More stationary phase equal to more degradation products. This is okay. So next for this is the so detector. This is for the detector pots, and also detector we can wash. We can do wash or not. We have water washing process need or not. Detectors.
It is needed.
Detector pots we can need for water washing process or no need. Detectors.
Yes, it is needed.
Yes, needed because of hydrocarbon is presence. So only hydrocarbons detect the thing with acetone set up these points. So this tool we can use for remove the detectors. This tool is remove the detectors. So this is for the detector pots. So we can remove. This is the detectors. This is for the detector pots. So then washed with water. So we can take, this is the on the, this is the detector pot and washed with water. So here washed with the water pots. So here you see, you can see washed with the water. This tool we can use. Detector is inside is present, so that's why we can do this tool inside the detector is present. Remove, then remove. So this is the collector rod. Electrometer is present here. So this is very short. We can column. We can do with the short. That is good conditions. Cracking is, that is bad conditions. So this is FID detectors. So what the ideal detector is, what is the detector is operate at high temperatures and stable and reproducibles and linear response and wide dynamic range, fast response. So this is under non-destructive. So this is the, so self-igniting columns plunger, and the sample gets vaporized and flows flow into the column and influence the carrier gas. So already I told this is GC and LC, and the two types of detector. This is for destructive type of detectors. What is the destructive type of detectors? The destructive detectors perform continuous transformation of the column analytes, burning, evaporation, and mixing with reagents. That type of is called for destructive type of detectors. So flame ionization detectors, nitrogen phosphorus, this type of detector is destructive detectors. So this is for non-destructive type of detectors. The non-destructive detectors are directly measuring some property of column analyte without any transformations. So the thermal conductivity detectors, that is for non-destructive type of detectors. So this is the flame ionization detector. This is the flame. This is for the so this is the fuel gas. When enter the fuel gas, so this is for the air. This is for hydrogen, air, and so when the hydrogen air is combined with this is the flame, the flame chamber. This is for the flame chamber, and this is for the oven, and the high voltage ion collector is present here. So the here gas plus hydrogen plus air. So what is the combustion products? So what is the forming? H2O, ions and the radicals and the electrons. So ions, the ions are directed using metal collector, brass or platinum, which further generate the currents. So the current is further analyzed using digital converter, and further a chromatogram is developed. So rate of ionization increase, current which is produced also increased. So depends upon the concentration of the hydrocarbon in the sample gas. So what is the disadvantage? It destroyed all the samples in the detectors. That time all the sample is destroyed. We can do recycle process. We cannot do for in these samples. So this is the limitations. So this is the limitations. So next, this is the advantage and the disadvantage. So please this sample when I am using for polar column I am using which is which column will have the lowest retention time highest. lowest retention time and the highest retention time. The stationary phase is polar. The stationary phase is more polar. So which compound elevate first?
Propionic acid. Propionic acid.
Stationary phase is polar, ma'am. Okay.
Yeah.
So which is elevate
More
first?
retention time. Propionic acid maximum retention time.
Oh, maximum retention time is propionic acid. Yes, correct.
Yeah.
Yes, because of boiling point, all the boiling point nearly equal. So boiling point equal, that time what we can do? Affinity. So boiling point very close. All the boiling point is very close. 140, 141, the not the very much, very less difference. So that time what we can do? Affinity. Affinity is very important. So stationary phase is more polar. So so acid is more polar. So polar is more interactions. So what is the highest retention time? That is for the propionic acid. So lowest reactions. So the propionic acid is highest retention time, and the 3,4 dimethyltryptamine is lowest retention times. So this is placed methyl cyclohexane, and this is the column also non-polar column. Stationary phase is non-polar, ma'am. Stationary phase is non-polar.
Octane.
So which is highest retention time and the lowest retention time?
Octane.
Octane, yes. Octane.
Yeah.
Which octane, ma'am? Here you can see boiling points. Different boiling point is present, ma'am. Here you can see all the compound is non-polar. Okay. So here you can see boiling point, which is very low boiling point.
Pentane.
Pentane is very low boiling point. So that is elevate first. So lowest retention time is pentane. So which one is high boiling point? Which one is high boiling point?
2,3 dimethyl.
Yeah, 2,3 dimethyl octane is, that is for the highest because of high boiling points. So this is the principle of the. So this is thermal conductivity detectors and the electron capture detector is present. So this is for the. So now why we called as a gas chromatography? Answer, ma'am, please. Why we called as a gas chromatography? Dr. Sajid. So others.
We are analyzing the gas.
Why we called as gas chromatography? Because gas is used as mobile phase in GC.
Yes.
That's why we can call for gas chromatography. So what type of gas is used in mobile phase? What type of gas is used as a mobile phase in GC?
Inert gas like hydrogen.
Yeah.
Nitrogen gas.
Inert gas. Inert gas used as a mobile phase in GC. So what are the most common mobile phase used in GC?
Helium, hydrogen.
Yeah, helium, nitrogen, hydrogen are most common mobile phase in UC. What are the type of detector used in GC?
TCD.
CG.
Thermal conductivity detector.
Flame ionization, TCD, ECD, and the nitrogen phosphorus detector, flame photometric detectors. So this type. So which is most commonly used detector in GC? Which is most commonly used detector in GC?
TCD.
No, FID. So FID, flame ionization detector, is most commonly used detector in GC. So what is the difference between FID and TCD? FID, TCD. Any idea what is the difference between FID and TCD? So FID means flame ionization of organic compound by its application uses for head phase analysis. So this is for head phase analysis. In case This is for solid form dissolved with solvent. So that heating the specified time, heating the specified time, that time the upper layer only we can take. So upper layer only we can take. That is for head face. So the head face is two phase static head face and dynamic head face is there. So we can analyze this only head face. So here sample is present, and so when heated, that time the upper layer only we can inject, we can take through the syringe and inject the sample. We can detect in GC. So this is for the dynamic head phase and the environmentals. So analysis of drinking water and the wastewater, the soils and the industrial waste. You can use for head phase auto samplers. We can use for head phase auto samplers, and the food also we can use for head phase organic volatile impurities. So and what is the difference between automatic layer sample and the head phase samples? So automatic liquid in the sample inject liquid and vaporize in column, and head phase converted to liquid solid into gas form. So head phase but the head phase convert to liquid solid into gas, but automatic liquid sample inject liquid and vaporize in columns. So how many types of auto sampler in GC? How many type of three type of auto sampler in GC? Of auto sampler is present in GC. Ratio means in two parts. Minimum parts goes into the column and the maximum part is went out. That is for the split. So that is for the split ratio. And which is best practice for split injection or splitless injections? So split injection is best injection parts. Why temperature program is required, madam? Why temperature program is required? Why temperature program is required?
For better illusion, for better separation.
Yeah. Principle. What is the boiling point? GC. What is the principle? Boiling point is importance. That's why. So the elevate high boiling. The elevate high boiling point molecule fast and the EC. That's why using for what type of molecule elevate first in GC? Madam, what type of molecule elevate first in GC?
Low boiling.
Yes, low boiling. Yes, low boiling point molecule elevate first in GC. Fast and accurate. Thank you, ma'am. Please, any doubt, please ask me. I will explain to you. No problems.
Thank you, sir.
Dear faculty members.
Thank you, sir, for the enlightening talk.
Any doubts? Explain.
Any question?
Yeah. Yes.
Any question from the
We
participants?
want to see this, and we want to program or want to operate this.
What, ma'am?
Excellent, sir. We are curious to operate this in GC.
Yes, ma'am. Thank you, ma'am. Thank you. Very nice. Anytime if you want any doubts in GC, ask me. I will explain to you. No problems.
Yes, sir. We want to have more interaction with you, more sessions.
Yes, ma'am. Tomorrow also I will come, ma'am. Tomorrow also is there.
Any other question?
Really, it was a wonderful lecture,
Yes,
and
ma'am.
I expect more participation from participants. Thank you, sir, for the enlightening. All participants should be interactive. Now, please clear your doubt. We are blessed that sir is with us.
Hello. Hello, sir.
Yes, ma'am. Yes, ma'am. Please.
Sir, actually, I want to know that if a column is damaged or something water molecule are present in the column, then how can we correct it?
Column once damaged, we can new column only we can put, ma'am.
Okay, new column.
Yeah.
Nothing
So
other.
that's why we can do very careful to analysis.
Okay.
Once column is damaged, we can nothing is wild.
Okay.
So what
Can't
is,
we use the traps?
Okay, sir. Thank you, sir.
But can't we use water trapper,
Yeah.
or air trapper?
Yeah, that time deductor we can deduct for another FID is not possible now. We can deduct for another deductor is there for steam, nitrogen, for gases analysis, steam analysis.
Okay, sir. Thank you, sir.
So many
Sir,
deductors present, ma'am.
sir,
FID only most of the organic compound we can detect for FID, but we need particular for pesticides. That time ECD, electron capture detectors, we can use for pesticide samples. So the different kind of samples, different directories for present. In case phosphorus is present, we can phosphorus director we can use.
Okay, sir.
sir, detector washing is always required in after completion of each sample.
Yes, ma'am, because carbon is present. That when flame, at the time the carbon is present. Only the detector counting only carbon. How many carbon is present, that only we can detect. So the detector find out only for hydrocarbon. How many carbon, hydrogen is present, carbon is present. So more carbon is present, the peak intensity is more. Less carbon is present, peak is less. So that is the carbon is detector, carbon is present. So that we can remove that carbons. Not that much. We can monthly one time. That is enough.
Sir,
Daily.
what peaks will be receiving? Can you discuss tomorrow its
Ah,
interpretation?
yes, ma'am. Yes, ma'am. Definitely, no problems. Yes, tomorrow for UV spectroscopy. That we can.
Thank you, sir.
Okay.
Anybody wants? Okay, thank you, sir.
Sir, I'm missing tea, है ना? You are really tired, na?
Yes, yes, ma'am. Obviously.
Thank you, madam. Thank you.
Anna, you
Thank
have
you so
taught
much.
continuously for 2.5 hours, na?
Yes,
Really,
ma'am.
really, na? Your stamina is really good, na?
Okay.
Please have tea, sir.
Okay. Okay, madam. Thank you, madam.
Thank you
No
very
problem.
much. Thank
Thank
you.
you.
Okay.
Thank you,
Thank
sir.
you.
I hope
Okay,
our
ma'am.
audience
Thank
Thank you
you.
so
Thank you.
much.
must have
Thank you
been
so much.
enriched in
So
knowledge.
tomorrow we will be meeting.
Yeah, yeah. Tomorrow also we will discuss.
Tomorrow
No problem.
at
All,
2:30.
Okay.
all participants fill feedback form of today's session.
Thank you.
Okay, thank you, sir. Thank you very much.
Okay, ma'am.
More participation is required. Na? Today, Neena ma'am and Ethel madam and Sani
Meena
madam
ma'am,
was very
and
active.
Karuna ma'am.
Thank you, ma'am.
Yes.
So we expect active participation from others also. So thank you all. Meeting tomorrow once again.
Thank you. Thank you, ma'am.
Thank you, sir. Thank you, ma'am.
Thank you, Venkateshan, sir. Thank you, sir. Thank you, Neena madam. Thank you, Karuna ma'am.